welcome back to the deep dive. If you are, preparing for a meeting, trying to get up to speed on a new field, or maybe you're just driven by that fundamental curiosity about how the world makes structured sense of its own recorded history, then you are definitely in the right place. Our mission here is to take that overwhelming, just chaotic reality of information overload and give you the structured knowledge you need to cut straight to the core.
And we live in an era that's, well, it's universally defined by big data, right? But the vast majority of that data, and I mean, whether we're talking about ancient historical treaties, modern political speeches, complex corporate transcripts, or just the absolute fire hose of social media feeds, it's textual.
And stubbornly unstructured.
Exactly. From a purely methodological standpoint, it's just noise. It's noise until you figure out a systematic way to parse it.
And that is exactly where we're going today. We are exploring the essential methodological bridge that turns that overwhelming, subjective, unstructured human discourse into a foundation for rigorous scientific inquiry. We're decoding the chaos of human communication through the lens of content analysis.
That's absolutely it. Content analysis is, you can define it as a sophisticated, really systematic research tool. It's used to determine the presence, the meaning, and even the relationships of specific words, themes, or concepts within a given body of qualitative data.
So it's the core mechanism. It translates all this complex, organic human communication into something quantitative, or at least something systemically structured.
Yes. It's not just a fancy way of saying reading carefully.
Right. It's a formalized technique.
It's a scientific method. The goal, the whole point, is inference. The methodology allows researchers to make valid, reproducible inferences about three crucial aspects of communication.
Okay. What are they?
First, the antecedents, which basically means understanding the sender's intent or the context of production. Why was this message created?
Okay, the why behind it.
Second, the characteristics of the message itself, the systematic description of the text. What does it actually say? And third, and this is often the most important, the consequences of that message.
The effect.
The measurable effect it has on the audience and on society. So it provides this holistic, three-part framework for really analyzing communication.
I really appreciate that emphasis on inference, because if we're making valid inferences, we must be treating this more like a science than, say, literary criticism.
That's the goal.
Now, right away, our source material introduces this fundamental tension, a core duality that's inherent in the method, and it really helps us understand its breadth.
It does. This core duality is, it's beautifully captured by this analogy of an apple orchard. Content analysis operates on a continuum of, let's call it philosophical depth or epistemology.
An apple orchard, okay?
If you deploy it as a purely quantitative instrument, your focus is on volume and statistics. You're literally just counting the apples to understand the total yield, the frequency, the prevalence of specific items.
Simple counting. How many apples are there?
Exactly. But if you shift that focus, if you use it as a qualitative framework, you're moving away from sheer volume. Now you're tasting the apples. You're sampling them to understand the variety, the subtle flavor, the critical nuance.
Ah, I see. So it's the difference between yield and flavor.
Precisely. Both approaches use the same fundamental material, the fruit, or in our case, the text. But they're seeking different kinds of knowledge. The quantitative approach wants generalizable facts about the whole harvest.
The big picture.
While the qualitative approach seeks deep, contextualized meaning about a specific selection. And both, as the analogy implies, are absolutely necessary for a complete textured understanding of the entire social reality that the text represents.
Okay, so let's unpack this historically. Before we can get to analyzing millions of tweets on a Sunday afternoon, we really need to trace the lineage of this method. How did analyzing something so subjective, like a sermon or a political speech, become a standardized scientific endeavor? The roots go surprisingly deep.
They absolutely do. We really start with the Weberian roots in the late 19th century. Max Weber himself, he didn't have the term content analysis, of course, but his interpretive sociology established the intellectual scaffolding for it.
So how did that work? Weber is famous for these monumental works like The Protestant Ethic and The Spirit of Capitalism. How did textual analysis factor into such a massive sociological project?
Well, Weber's goal was grand. He wanted to unveil the underlying value systems that dictated vast macro-sociological change. And in that work, He performed systematic, albeit manual, analysis of religious texts and cultural documents.
Like what specifically?
Specifically, Protestant sermons, the writings of figures like Benjamin Franklin, the rules of religious sects. He wasn't just, looking to count how many times the word thrift appeared. He was interpreting the system of values that encouraged people to live these ascetic, hardworking lives.
And that, in turn, inadvertently fueled the accumulation of capital.
Which is what we now call the spirit of capitalism. His insight wasn't statistical, it was structural. He argued that ideas and texts didn't just reflect society, they actively shaped its economic foundations.
That's a huge claim. So he saw text as a window into the prevailing worldview, the Weltanschauung.
Exactly. And this intellectual tradition, it persists powerfully today in what's called comparative historical analysis, or CHA. Researchers in that field systematically study vast archives of historical documents, government records, cultural texts, all to explain these large-scale outcomes.
Like revolutions or the origins of welfare states.
Right. They're still performing deep systemic content analysis manually and meticulously to understand how values embedded in historical communication drive these profound societal outcomes.
Okay, so that brings us to the formalization. If Weber provided the intellectual foundation, Harold Lasswell, he provided the architectural blueprint. He's the one who turned this interpretive work into a rigorous structural methodology.
Yes. Lasswell is unequivocally the key figure in the mid-20th century, particularly from the 1930s onwards. And the driving force for this formalization, it wasn't abstract academic curiosity.
Oh, it was practical.
It was acute political necessity. It was the need to understand and counter wartime communication and, propaganda during and after World War II.
Of course. We were in a global communication crisis trying to figure out what the enemy was broadcasting and what its effect would be.
Precisely. Lasswell introduced content analysis as a crucial tool for what he termed the surveillance of the environment. This meant systematically tracking messages to assess threats, measure morale, and understand shifts in enemy and allied rhetoric.
So he formalized it to be repeatable, objective, quantitative.
And moved it squarely into the realm of social science.
And he gave us that enduring framework for all communication research, something so foundational that it's still taught in every media studies program, the 5Ws model.
It's a marvel of structural elegance. It divided the entire communication process into 5 distinct and measurable areas of study, and it formally placed content analysis within that ecosystem.
Okay, so let's walk through them. The first W, who?
That's control analysis. It investigates the sender, the source, and their primary intentions or biases. Who's behind the message?
Okay, makes sense. The second says what?
And that's the heart of our discussion today. That is content analysis. The systematic, objective description of the message components themselves, independent of the sender or the receiver.
The third, in which channel?
That's media analysis. It's the study of the medium of transmission radio, newspaper, television, now social media, and how that channel influences the message.
Right, the medium is the message, or part of it. The fourth, to whom?
Audience analysis. Identifying the target demographic, their characteristics, their existing beliefs.
And the final, critical step, with what effect?
Effects analysis. Measuring the message's resulting impact, its adoption, or any alteration of behavior in the audience. Did it work?
Lasswell's enduring legacy, then, is that he aimed for, optimum objectivity, precision, and generality.
Exactly. And that formal commitment established what we call the manifest tradition of content analysis. It focuses squarely on visible, countable symbols.
Like tracking the frequency of ideological terms or favorable mentions of a politician?
Yes, all about quantification to track political and public opinion.
That approach makes perfect sense for studying clear, targeted communication like propaganda or news coverage. But the field shifted pretty dramatically away from just explicit political messages to the total cultural environment in the late 1960s, thanks to George Gerbner.
Ah, yes. Gerbner.
This is where content analysis started looking at the air we breathe, not just the headlines we read.
Gerbner's work on the Cultural Indicators Project, it represents one of the longest and most ambitious applications of content analysis ever undertaken. It focused on long-term television broadcasting and was the empirical engine behind what we know as cultivation theory.
And the core idea of cultivation theory is that consistent exposure to the repetitive patterns of TV content slowly cultivates your long-term perception of reality, right? It makes you see the real world through this distorted lens of fiction.
That's it. The central question Gerbner was trying to answer was about the fundamental, pervasive relationship between the manufactured world of television and the perceived world of reality.
He saw TV as our central storyteller.
He argued that television, unlike a newspaper, had become a centralized cultural system. It was the storyteller of our time. And to study this system, he needed a method that could capture its aggregate message, not just individual programs. So he designed this really robust tripartite method.
Okay, 3 parts. First, he looked at who was holding the reins. Institutional process analysis.
Right. This involved investigating the corporate and political decisions directing the flow of media messages. You had to understand the commercial and structural context, who funded it, who owned the network, to understand why the message system looked the way it did.
Okay, that's the context. Second, the message itself. Message system analysis.
This was the grueling, meticulous content analysis component. Gribner's teams, they didn't just watch TV casually. They conducted rigorous, systematic analyses of week-long samples of primetime television drama.
And the goal was to find patterns across the whole system.
Consistent aggregate patterns. For example, they weren't just counting violence in one crime show. They were counting the prevalence of violence, its demographics, who was the victim, who's the perpetrator, across an entire year's worth of sampled content. They also rigorously tracked the systemic representation of women, minorities, and specific occupations.
Can you give us a concrete example of a finding from that message system analysis? Something that illustrates the depth of the data they were uncovering.
Certainly. One of the key findings was the sheer overrepresentation of violence compared to its occurrence in real life, especially regarding demographics.
So not just that there was violence, but who was involved.
Exactly. For instance, in their content samples, women were significantly more likely to be victims of violence than perpetrators.
Yeah.
And older, poorer characters were often marginalized or depicted as victims. This all fed a latent fear that viewers then internalized. It wasn't just that violence occurred, it was the patterns of power and vulnerability that were revealed by the systematic counting.
And the third step closed the loop on the audience. Cultivation analysis.
That was the survey component.
Yeah.
They would survey heavy viewers of television, people consuming 4 or more hours a day, and compare their perceptions of the real world with those of light viewers.
And they asked things like, do you think crime rates are higher than they really are, or do you fear walking alone at night?
That's right. And this gave rise to the famous mean world syndrome. Heavy viewing cultivated the perception that the real world was far more dangerous and mean than actual statistics suggested, simply because TV consistently depicted it that way.
Wow. So what the source material really highlights here is the immense insight that this project delivered. Content analysis could reveal these latent, cumulative effects that no single viewer, no matter how clever, could perceive just by watching TV.
Because the individual viewer watches a narrative.
But Gerbner analyzed the whole system of narratives. The message wasn't a plot point. It was the aggregate pattern of representation across the whole broadcasting machine. That's profound.
It shifted content analysis from just being a descriptive tool to being a critical tool for revealing deeper, systemic social patterns that accumulate over time.
Okay, so since Lasswell and Gerbner, the methodology has really matured, and it sounds like the architecture a researcher selects is critical. It all comes back to their core epistemological stance. What kind of knowledge are they actually after?
Exactly. Are they seeking objective facts they can count, or are they seeking nuanced, subjective interpretations?
Let's dive back into that core duality then, quantitative versus qualitative. How do they approach the same text with such fundamentally different goals?
Right. So quantitative content analysis, or QCA, is fundamentally deductive. It starts with a broad theory. Let's say political candidates use fear rhetoric more often during economic recessions. And then it seeks to test that hypothesis by systematically counting specific manifest textual elements.
So QCA begins with a map of where we think we're going, and we just use the text to confirm the features on that map.
Precisely. The goal is prediction, generalization across a large corpus, and of course, frequency counting. The focus is exclusively on the manifest content, what is visible and quantifiable right there on the surface.
And the output is just numbers.
It's statistics, numerical values, trends that can be correlated with other macro-level data like unemployment figures or stock market volatility. If a QCA researcher counts the frequency of the word crisis in 50 years of political speeches, that frequency is their proxy for significance. QCA stops at the numerical relationship.
But if we're dealing with human language, we know that manifest content is only part of the story. Which brings us to qualitative content analysis.
Qualitative content analysis, or the other QCA, is fundamentally inductive and interpretivist. The logic moves bottom up, from the data to the theory. The The goal here is deep understanding, description, and interpretation, focusing heavily on the latent content,
The hidden meaning.
the underlying, sometimes hidden deep within the text, meaning.
A skeptical listener might say, okay, if you're interpreting the hidden meaning, how is that scientifically rigorous? What separates scientific QCA from, say, just literary criticism?
That's a crucial question, and the separation lies in the systematic process. QCA must still use defined, replicable steps, which we'll get into, but its core assumption is interpretive.
Which is?
The assumption that a single, nuanced mention of a concept in a critical context may be exponentially more significant than 50 mentions in a trivial context.
Oh.
QCA uses repeated words or ideas not just for frequency, but as highlighters, as indicators of where the deepest, most contextually rich interpretation is required. The difference is that QCA wants to know the quality of the flavor, not just the number of apples.
So QCA acknowledges this latency flaw that QCA overlooks, that the most important truth in the text might be the one that is carefully obscured or only mentioned once.
Exactly. If we're analyzing a company's communications, QCA might count 50 mentions of synergy and 1 mention of ethical compromise. QCA focuses on the 50.
But the qualitative approach.
QCA focuses its interpretive effort on that single mention, recognizing its disproportionate latent significance.
Now let's refine the mechanics of what we count. We can move beyond just simple frequency counting of single words and look at the relationship between words. You have conceptual versus relational analysis.
Right. Conceptual analysis is the foundation. It focuses purely on the presence and frequency of discrete, singular concepts. It's the simplest form of counting.
Like counting how many times sustainability appears in a decade of report.
Exactly. It quantifies themes to understand their sheer prominence or absence. But as you know, as soon as we deal with human language, meaning is generated by context. The single word sustainability doesn't mean much until it's placed next to something else.
That's the limitation of conceptual analysis, then. It treats all concepts as these isolated variables.
And relational analysis, or semantic analysis, corrects this by examining the relationships of the semantic networks between those concepts. It operates on the principle that meaning isn't inherent in a word itself. Rather, meaning is constructed when symbols are connected to other symbols.
So if we look at that word sustainability, how would relational analysis process it differently?
Relational analysis maps its associations. It would look at the structure of the text surrounding that concept. For instance, does the text consistently link sustainability to compliance, cost reduction, and risk mitigation?
Or does it link it to innovation?
Or to innovation, long-term growth, and competitive advantage? Mapping these links reveals the narrative structure and the inherent value system of the author. You get this holistic, contextual view of meaning construction.
That distinction, counting the words versus counting the connections, is key. Finally, let's talk about the direction of theory when you're designing the study. Deductive versus inductive coding.
These two approaches define how the codes are created and applied. Deductive coding is the top-down approach. It's used when your purpose is to confirm or extend an existing established theory.
So the researcher starts with a pre-existing codebook, right? The categories are already defined from prior research.
Exactly. The conceptual buckets are ready-made before you even touch the raw data. It's confirmatory research. You're focused on whether your data fits the existing theoretical map. The downside, of course, is that you might miss novel phenomena that don't fit into those existing buckets.
Conversely, inductive coding is the bottom-up approach, which we often associate with grounded theory.
Inductive coding is used when knowledge is fragmented, or when the primary goal is pure theory generation and exploration. Here, the researcher generates, or derives, the codes directly from the data itself.
So no preconceived categories.
None. You read the raw text, you let the categories emerge organically, and then you build the code book from those novel themes. This is essential for exploratory research and allowing entirely new concepts or narratives to emerge that no one had thought of before.
So deductive coding tests the current map, and inductive coding draws a new map based on the terrain you've observed. That seems like a powerful intellectual tension right there in the architecture of the method.
It is. The choice defines the entire project.
Okay, now we move from the abstract architecture into the rigorous application. If you wanted to run a content analysis project yourself, how do you make that transition from raw, messy text to a rigorous scientific structure? It has to be a systematic, step-by-step process to ensure validity and replicability.
This is where the rubber meets the road. The first step is fundamental: data preparation and sampling. First, you have to clearly define your corpus, the body of text you will study, whether it's 20 interviews, 50 years of newspaper articles, or a million social media posts.
And a crucial detail that's often overlooked, the qualitative data has to become text.
Absolutely. Any qualitative source, like audio recordings of interviews or focus groups, must be transformed into complete, accurate written transcripts before analysis can even begin.
And then you define the unit of analysis. What exactly is that, and why is that decision so consequential?
The unit of analysis is the basic segment of text to which a code will be applied. Is it a single word, a full sentence, a complete speech, or an entire article? The decision profoundly shapes the scale of your interpretation.
How so?
If your unit is too small, say single words, you lose all context. If your unit is too large, like entire paragraphs, you risk coding conflicting or multiple meanings simultaneously. It has to be carefully defined to capture the right level of meaning.
Okay, so the next two steps, 2 and 3, they focus on making the data manageable without losing that essential context. Step 2 is the identification of meaning units.
Right. Meaning units are those segments of text that convey a single, coherent thought or piece of information that's relevant to your research aim. As you read the text, you segment it. Again, it's a balancing act. The units have to be manageable enough that you can code them distinctly, but robust enough to maintain the conversational or narrative flow.
And then comes step 3, which is where the systematic reduction happens. Condensation and abstraction. This feels like the true intellectual bridge between the raw voice of the participant and the structured data point.
Condensation is absolutely critical, especially in qualitative work. It involves shortening the meaning unit, sometimes radically, while strictly preserving its core essential meaning. This practice ensures that while you abstract the data, you don't lose the authentic voice or context of the original text.
Can we walk through another concrete example of that?
Sure. Imagine the raw text from an interview is, "It was a real shock, honestly, when they suddenly announced the layoffs. I hadn't expected that kind of disruption." The researcher might identify this as a meaning unit.
Okay.
The condensed unit becomes, "Sudden layoff announcement caused shock." The resulting code could be something like, "Unexpected disruption." We've preserved the core shock and the unexpected nature without all the superfluous language.
You've captured the emotion and the event, but made it manageable for comparison.
Or take another one, focusing on a relational aspect. Raw text. My supervisor, who had always been a great mentor to me, suddenly became very distant and refused to discuss my project. The condensed unit could be, mentor became distant, refused discussion. The code might be, loss of support or mentorship withdrawal. This systematic reduction is what allows a researcher to handle massive volumes of complex human narrative without collapsing it into oversimplified categories too early.
And this detailed preparation leads us to step 4, which you identified earlier as perhaps the most essential instrument of reliability in the whole process, the codebook.
The codebook is the foundational governing document of the entire study. It has to be transparent, living proof of your scientific rigor. It must list every single code, provide its precise, unambiguous definition, detail the inclusion criteria.
So when should this code be applied?
And the exclusion criteria, when shouldn't it be applied? And it should provide multiple examples of its proper application.
It sounds like a legal document for coders.
In many ways it is, because it ensures standardization across multiple coders and across time. And the codes themselves, they exist in a structured hierarchy of abstraction, helping the researchers structure their findings from the specific to the universal.
Okay, so starting with the most specific level, codes.
Codes are the descriptive labels, usually 1 or 2 words assigned directly to those condensed meaning units. Next, you group those codes into categories.
And categories are just clusters of similar codes.
Right. They share a common similarity and generally address the factual, manifest content, the who, what, or when of the text.
And finally, the highest level of abstraction brings us to the ultimate intellectual payoff, the themes.
Themes are the macro-level concepts that express the underlying latent meanings that run across multiple categories. They address the why or how questions of the research. For example, codes about salary and benefits might form a category called compensation, but that category might contribute to a broader theme called perceived institutional inequity.
And the codebook keeps all of this straight.
It's what prevents coder drift, where even trained researchers unconsciously change their interpretation of a code over time. It ensures the whole team remains consistent.
Okay, so finally, steps 5 and 6 deal with the execution and the accountability of the research. Step 5 involves iteration and consistency checks.
Exactly. The process isn't linear, which is why methodologists call it the hermeneutic spiral.
Oh, what now?
It's a hermeneutic spiral. It just means you're constantly moving back and forth between the coded parts, the specific data points, and the whole text, the original narrative. If, during coding, a code doesn't quite capture the meaning, or if a new, unexpected theme begins to emerge, the researcher has to return to the initial meaning units and revise the code book or refine the abstraction process.
So you're always checking your work against the source.
Constantly. And then step 6, analysis and reporting, brings us back to that crucial concept of transparency. The final report has to demonstrate absolute auditability.
Meaning an outsider has to be able to follow your work?
Yes. The reporting needs to be so detailed, so transparent about the process of condensation, code derivation, and category construction that an external party, a scientific auditor, could theoretically follow the entire decision trail. This verification ensures that the findings are robustly grounded in the actual data, rather than being mere reflections of the researcher's preconceived notions or biases.
Okay, so that rigor is constantly being challenged because, at its heart, this method relies on human interpretation. In the positivist scientific tradition, you have to prove that your results are consistent, that's reliability, and that they're accurate, that's validity.
And when human judgment is involved, establishing those criteria presents unique, often profound challenges, especially when multiple people are involved in the process.
This is where we run straight into the problem of inter-rater reliability, or IRR.
Yes. IRR measures the critical degree to which two or more independent, trained coders agree in the coding of the exact same segment of text. If you employ two trained researchers and they apply fundamentally different codes to the identical meaning unit, the study has low reliability.
And if the results aren't reliable, they can't possibly be valid.
You can't trust the result, and any policy recommendations based on those findings are suspect.
So the most basic first attempt at measuring this consistency is simple percent agreement. Why is that metric so methodologically flawed?
Percent agreement, which is just agreements divided by total items, is highly misleading because it fails to account for agreements that occur simply by random chance.
Can you give an example of that?
Sure. Imagine two coders are asked to code a very simple binary choice, where one code, let's call it code A, is used 90% of the time. If both coders simply guess code A every single time, they will achieve 90% agreement.
Wow, 90% sounds great.
It does, but it's an illusion. The remaining 10% of the data, which is the complex, unique, potentially contradictory data, is likely coded erroneously or randomly, so that high percent agreement gives a false sense of security, masking poor reliability in the crucial nuanced parts of the data set.
Okay, so we need more robust statistics that move beyond chance. This brings us to Cohen's kappa.
Cohen's kappa is a much superior statistic because it calculates the expected agreement, what you would anticipate based purely on the frequency distribution of the codes, and then compares that to the observed agreement, mathematically correcting for the role of chance.
It gives you a truer measure of the consistency.
Yes. But even kappa, while better, is still a point of methodological debate, particularly around what are acceptable thresholds for publication.
So different fields have different standards.
They do. While a kappa score of 0.80 is generally considered the standard for reliable data, some fields, particularly those dealing with subjective human states like pain or emotion in health research, have controversially accepted values as low as 0.41. Methodologists argue that accepting anything below 0.60 means the interpretation is too heavily reliant on the individual coder's judgment rather than the rigor of the codebook.
Okay, so this intense pressure for rigor leads us to what is widely considered the ultimate statistical gold standard for measuring reliability in content analysis. Krippendorff's alpha, or alpha.
Krippendorff's alpha is the preferred measure in the social sciences because of its immense statistical flexibility, which addresses many of kappa's limitations. Alpha is universal. It can handle any number of coders, it manages missing data elegantly, and crucially, it works with various measurement scales, nominal, ordinal, interval, and ratio data, whereas kappa is often limited.
That flexibility is critical, especially in large-scale studies where you might have varying levels of measurement and multiple team members.
And it provides clarity. The consensus thresholds for alpha are now gospel in many disciplines. Alpha is perfect agreement, a theoretical ideal. However, an alpha deleo 0.81 means the data is highly reliable and safe for drawing substantive, publishable conclusions.
And what about the danger zone? What score tells the researcher, you need to stop and fix your codebook immediately?
The critical threshold is an alpha 0.6797. Below this level, the data is typically considered unreliable, suggesting severe issues with the codebook definition, the training of the coders, or the complexity of the categories. The ethical mandate is often that data below this threshold must be discarded.
So you have to check this constantly.
Modern research practice demands that reliability testing be conducted throughout the project, not just at the end, to catch any coding drift before it contaminates the entire dataset.
Now, that's the quantitative positivist standard. But what about qualitative researchers who reject the whole idea that human language can ever be reduced to objective facts? How do they ensure their work is trustworthy?
Qualitative methodologists often substitute the positivist term reliability with the much broader concept of trustworthiness. This concept acknowledges the inherent subjectivity of interpretation while still demanding rigor.
And it involves different criteria.
It's a broader set of criteria.
Yeah.
Credibility, how believable are the findings? Transferability, can these findings apply elsewhere?
Yeah.
Dependability and confirmability.
So they aren't relying on statistical scores like kappa or alpha then. What's their mechanism for proving rigor?
They rely heavily on audit trails. The audit trail is a comprehensive, meticulously documented record of every single decision made throughout the research. It includes those detailed coding manuals, field notes, theoretical memos about why a theme was named a certain way, and documentation of all data reduction steps.
So the goal is not to prove that another researcher would necessarily reach the same subjective interpretation,
Right.
but to prove that the findings are rationally and transparently grounded in the data.
Exactly. It allows an external auditor, or any interested party, to follow the researcher's entire decision-making journey and verify that the conclusions flowed systematically from the raw data and the stated theoretical framework, thereby ensuring the conclusion is not merely researcher bias masquerading as findings. It shifts the burden of proof from numerical agreement to process transparency.
That discussion about the struggle for objective truth in content analysis, its core crisis of reliability, is the perfect bridge to our next section. Since content analysis sits so uncomfortably between positivism and interpretivism, how does it position itself against other methods that embrace subjectivity? If someone asks, aren't content analysis, discourse analysis, and thematic analysis all just methods for reading text? What are the clearest, most critical boundaries we must draw?
That's where the epistemology becomes paramount. The key is understanding that while they all read text, they ask fundamentally different questions about the text's function. And the boundary between content analysis and discourse analysis is the sharpest. It revolves entirely around how the method treats context and power.
Okay, let's start with our core method, content analysis, or CA.
Content analysis, particularly in its quantitative form, seeks to abstract the text from its immediate social and political context to identify objective, recurring patterns. It treats the text largely as a container of meaning that can be systematically categorized, counted, and aggregated.
So it asks the descriptive question, what is being said, and with what measurable frequency?
Exactly. It aligns with positivist or post-positivist paradigms that believe systematic observation can reveal objective social facts.
Discourse analysis, or DA, essentially takes issue with that abstraction, insisting that text is inseparable from its context.
DA is deeply interpretive and often critical. It focuses not merely on what is said, but on the social and political function of language. DA assumes that language is not a neutral vessel for transmitting information. Rather, language actively constructs social reality, power dynamics, and systems of inequality.
So it's asking a different question.
It asks the critical question: how is language being used to maintain or challenge existing power structures? It aligns with constructivist or critical paradigms.
Can you provide a high-stakes, real-world example that illustrates how these two methods would analyze the same piece of communication differently?
Let's consider a political debate where the topic is immigration. Content analysis might quantify the frequency of terms like border security, economic migrant, or legal pathways. It would track if candidate A used border security 50% more often than candidate B.
Okay, descriptive counting of manifest terms and discourse analysis.
Discourse analysis would ignore the simple frequency counts or use them only as a starting point. It would deconstruct how the language is deployed. For example, it might analyze how the phrase economic migrant subtly shifts the listener's focus from human rights to fiscal cost, thereby legitimizing certain exclusion policies.
So it's about the function of the words, not just their presence.
It would analyze the syntax and rhetorical strategies used to frame the immigrant as an other or a threat. The DA researcher is dissecting the language to reveal the ideological work it is doing to maintain power, not just describing its prevalence.
So CA describes the ingredients, but DA describes the complex recipe for power and persuasion.
Precisely. One is descriptive and generalizable. The other is interpretive and context-specific.
Okay, moving on. The boundary between content analysis and thematic analysis, or TA, seems much blurrier, especially in their qualitative forms. They both deal with identifying patterns.
They overlap significantly, to the point where sometimes they are used almost interchangeably. However, thematic analysis is generally understood to be a purely qualitative method. Its sole purpose is identifying, analyzing, and reporting patterns themes within a dataset.
And it doesn't typically involve any systematic quantification?
None. The primary goal is rich, detailed, comprehensive description and interpretation of the data. If a researcher performing thematic analysis notices a theme appearing 50 times, they might mention it, but they wouldn't use that number to infer significance.
So importance is determined purely by the researcher's judgment of the theme's centrality and richness, not its numerical presence.
That's the key operational difference. Qualitative content analysis, even when deeply interpretive, it retains a connection to the systematic, countable elements of the manifest data.
So qualitative CA, while seeking latent meaning, still often involves quantifying code frequency to inform or infer the importance of a concept. It remains tethered to that systematic structure inherited from Lasswell.
Yes. QCA aims for description that is structured, systematic, and potentially quantifiable, even if the primary goal is interpretive depth. TA is purely focused on that interpretive depth, often yielding a richer description of the themes, unconstrained by numerical boundaries.
Okay, that makes sense. So let's talk about the future. It seems like this entire field is undergoing its most significant methodological transformation since computers were first used to process text back in the 60s.
It absolutely is. The emergence of large language models, or LLMs, powered by generative AI, has radically altered the scale and speed at which we can analyze communication.
We've moved beyond the simple early days of automated analysis. What were the limitations of those traditional automated tools that the new LLMs have suddenly overcome?
Traditional automated analysis methods like bag of words or simple dictionary-based sentiment analysis, they treated text crudely. They often couldn't capture context. They failed miserably at understanding crucial elements of latent meaning, like negation.
I am not happy about this.
Right. Or sarcasm or complex syntax. They were good at counting simple frequencies, but terrible at capturing meaning. LLMs, with their vast training data and sophisticated transformer architectures, have revolutionized this. They are now acting as sophisticated zero-shot data annotators.
That term, zero-shot, is jargon we need to unpack. What does it mean for content analysis?
In traditional machine learning, zero-shot refers to the model's ability to follow complex instructions and apply codes based purely on a detailed prompt, the codebook alone, without requiring the researcher to manually code hundreds of examples for the machine to learn from.
So I give the LLM my detailed, rigorous, human-designed codebook, and the model can apply those rules instantly to millions of documents without prior examples. That's an astonishing leap in efficiency.
The efficiency gains are truly transformational. LLMs can process millions of documents in a matter of hours, a feat that would have required large human teams years of painstaking, expensive work. This massive scalability finally provides the potential to conduct deep, context-aware, qualitative analysis on a quantitative scale.
The holy grail of big data research.
Pretty much.
And what about validity? You mentioned earlier that the old algorithms were black boxes. Have LLMs improved the transparency of the coding process?
They have. The crucial innovation is that advanced LLMs can provide chain-of-thought reasoning. Unlike previous algorithms, which simply outputted a code, a sophisticated model can explain why it applied a specific code to a segment of text, referencing the text and the rule in the codebook.
So it shows its work.
It does, and that capacity for internal explanation fundamentally enhances the auditability and validity of the automated process.
Are the results truly comparable to human judgment? Are we seeing data that suggests models like GPT-4 can replace human coders?
We are seeing evidence that LLMs are achieving human-equivalent interpretations in empirical studies, especially in well-defined coding tasks. For instance, in socio-historical coding projects, tasks requiring nuance and contextual awareness, GPT-4 has achieved Krippendorf's alpha scores of 0.79 or higher.
Which is approaching the reliability of trained human experts.
It is. In healthcare studies, they show nearly 100% consistency in identifying broad, manifest themes like chronic pain,
That makes the technical argument for AI use almost irrefutable. But as efficiency rushes in, the new crisis of validity emerges. Algorithmic bias. You stated that the internet, the training ground for these models, is not a neutral corpus.
This is the core methodological and ethical challenge for the future. LLMs internalize and reflect the biases embedded in the vast textual data they are trained on, which is predominantly English language, Western, and frequently reflects historical and cultural biases.
What concrete evidence do we have of this systemic bias being replicated in the model's output?
Research using global cultural data has demonstrated that models like GPT-4 exhibit a strong, measurable Western bias. Their default interpretations and value alignments correlate most closely with data originating from English-speaking Protestant European cultures.
So when analyzing texts from other culture,
Consequently, when analyzing texts from, say, East Asia or the Middle East, the model may fail to accurately represent or even recognize the unique values or interpretations prevalent in those non-Western cultures.
so the models aren't just reflecting biases, they risk amplifying societal stereotypes regarding race, gender, and religion, and then injecting those stereotypes into the scientific process of content analysis.
Absolutely. Furthermore, the two persistent risks are hallucination, where the model detects codes or concepts that are simply not supported by the actual text, and oversimplification.
And what's oversimplification?
That's when the model, in its effort to generalize, collapses highly divergent, nuanced subthemes into a single generic category, effectively erasing critical nuance from the dataset.
This sounds like we're at an impasse. We can't go back to manual coding of massive data sets, but pure automation risks importing and amplifying systemic cultural bias. Where does this tension resolve itself?
The resolution, unanimously agreed upon by methodologists, lies in hybridization or human-in-the-loop systems. Pure manual coding is unsustainable with big data. Pure automated analysis is compromised by inherent bias.
So you use the machine for the grunt work.
The future requires leveraging the LLMs to perform the initial broad-scale coding, the high-speed counting and labeling of manifest content.
And then the human researchers step in to do the necessary critical work.
Exactly. Human researchers must focus on the most difficult tasks: designing the original codebook, training the model on the nuance, validating the outputs in a human-in-the-loop system, performing the deep critical interpretation of the latent content, and ensuring that the model's classifications, particularly in sensitive areas, truly reflect the original data's meaning.
The qualitative tasting of flavor.
Precisely. The human element moves from being the laborer to being the quality control and the critical interpreter.
Okay, let's synthesize all of this. What is the immense power of content analysis as a scientific methodology? But also, what are the serious demands and constraints it places on the researcher to maintain rigor and validity?
The strengths are numerous and make it a foundational method across the social sciences, media studies, and the humanities.
One of the greatest practical strengths has to be that it's an unobtrusive measurement.
This is a huge advantage because content analysis analyzes existing texts, diaries, archived communications, government reports, newspapers. It completely bypasses the Hawthorne effect.
That's the phenomenon where people change their behavior just because they know they're being watched.
Exactly. That contaminates so many research designs. Content analysis, by using records created naturally and independently of the research process, maintains the authenticity of the data.
And its capacity to track massive historical shifts over time is really unmatched.
The longitudinal capacity is unique. It's the only rigorous method capable of systematically analyzing social, political, or cultural change across extremely long periods. You can study centuries of political rhetoric or evolving media coverage using the same standardized structural methodology.
And now, with AI, we can finally achieve necessary scalability.
The integration with LLMs provides critical scalability, enabling researchers to rigorously handle true big data. It closes the gap between the interpretive depth previously limited to small, qualitative samples and the quantitative breadth of millions of data points.
And finally, its architectural flexibility allows for easy mixed methods integration.
Absolutely. Content analysis is uniquely suited for combining statistical rigor-like frequency counts and reliability measures with interpretive depth-like thematic analysis and latent meaning. This combination provides researchers with a double verification of findings. The quantitative data tells you where to look.
Well, that's prevalent.
And the qualitative data tells you why it matters, what it means.
Now for the serious demands and limitations. If a researcher isn't careful, where does the methodology fundamentally break down?
The biggest conceptual limitation is the risk of decontextualization and reductionism. By fragmenting text into discrete codes and units, the method risks losing the gestalt, the holistic narrative and flow of the original communication. A complex story or argument is reduced to a series of data points, potentially sacrificing the richness of the human experience being studied.
And this feeds into the problem of frequency being misleading, the latency flaw we discussed earlier.
Exactly. The reductionist flaw means a concept mentioned only once. A single warning sign, an unexpected confession, a crucial piece of counter-evidence may be the absolute key to interpreting the entire text. However, a quantitative frequency count would deem that single mention statistically insignificant and likely lead the researcher to discard it entirely.
Missing the truth hidden in the margins.
Yes. We also can't ignore the intensive human resources required for high-quality, high-reliability work.
Labor intensity.
It's a major constraint. Achieving high inter-rater reliability, particularly in complex qualitative analysis, demands extensive training, meticulous codebook refinement, and significant time and coordination among the research team. This requirement makes smaller, more thorough studies inherently expensive.
And finally, that core tension we started with, the counting versus the tasting, creates a sort of enduring epistemological ambiguity.
It does. The method fundamentally sits uncomfortably between two traditions: positivism, objective counting, and interpretivism, subjective meaning. Researchers must be crystal clear in their methodology about their stance. Are they claiming to discover objective facts that exist independently in the text, or are they constructing subjective interpretations based on a rigorous theoretical framework? Failing to articulate this distinction leads to confusion about the scope, validity, and applicability of the study's ultimate conclusion.
It's a lot to keep in balance.
The core lesson of content analysis remains that it is the essential lens through which we process and understand the recorded human experience. It has evolved dramatically, from Max Weber's meticulous manual analysis to the lightning speed of modern LLMs. It imposes necessary structure onto the chaos of communication, but we must remember that the structure we choose, our code book, our epistemology, our technology, it determines what we see, what we measure, and what we inevitably miss.
That brings us to a final, critical thought for you to mull over as you encounter vast amounts of analyzed data. Given the documented Western bias of current large language models and the fact that they are now the primary tool for performing initial coding on immense volumes of text, including documents from non-Western or marginalized cultures, the stakes of that initial processing are incredibly high. If human researchers are stepping in only to validate the output of a biased system, how much of the original data's unique, non-Western voice, its subtle cultural nuance, or its contextually specific meaning are we potentially collapsing, oversimplifying, or even outright hallucinating away in the name of efficiency? We gain incredible scale, but is that scale worth the inherent risk of erasing the vital nuance of diverse global voices?